Today on Uncommon Knowledge, is it time to take Charles Darwin down a peg or two?
Funding for this program is provided by the John M. Olin Foundation and the Star Foundation.
Welcome to Uncommon Knowledge. I'm Peter Robinson. Our show today, daring to question Charles Darwin. 143 years after Darwin published On the Origin of Species, his theory of evolution is still controversial. Of course, the overwhelming majority of scientists continue to champion Darwin, but a few people, bright people, have begun to wonder just how well evolution has held up and to put forward a few controversial theories of their own. Joining us today, two guests. Eugenie Scott is director of the National Center for Science Education. William Dembski is a fellow at the Discovery Institute and the author of Mere Creation: Science, Faith, and Intelligent Design. The theory of evolution is now so thoroughly understood and so completely borne out by the physical evidence that anyone who questions evolution must be, in the words of scientist Richard Dawkins, either, quote, ignorant, stupid, wicked, or insane, close quote. Bill?
Depending on what you mean by evolution, absolutely false.
You're not going to get a fight from me. That's a stupid thing to say.
That's a stupid thing to say?
Yes.
Oh, really? You're both brushing Dawkins aside. But Dawkins is one of your boys, though, isn't he?
Well, he's somebody who supports evolution and who thinks that evolution happened. I think evolution happened, too. But that statement's way over the top. I think we both agree with that.
All right. So Richard Dawkins, put your leash on. Let's go through a couple of senses of evolution as a layman like me understands it. Sense number one, evolution as change, merely as change. The planet has a long history. Certain living things that used to exist, such as dinosaurs, exist no longer. Certainly living things that now exist, such as human beings, appeared relatively recently in the history of the planet. Jeannie, you'd go for that.
Works for me.
And Bill?
Works for me as well.
Okay, so you then distinguish yourself from a fundamentalist or so-called young earth creationist who says the Bible claims the earth is about 6,000 years. That you don't.
I don't buy that.
You have nothing to do with that. All right. Sense number two, evolution in what I take to be a strict Darwinian sense. All living things, everything we see around us, from the blade of grass to me, are descended from one or a few common ancestors by a process of random variation and natural selection. You buy that one.
I would augment that. There are two things going on. One, the idea, the inference that we make from looking at lots of data that living things shared common ancestors. Secondly is, what is the mechanism that brings that about?
Those are distinct matters.
Those are distinct matters. But I separate descent with modification or common ancestry, the inference of common, and the mechanism. And one of the mechanisms is the one that you described, the
random
mechanism
variation and natural selection.
The mechanism of natural selection,
right,
which involves genetic variation and adaptive value of the variance within a particular environment. But there's other mechanisms as well that may explain parts of the evolutionary process.
Okay, so do you distinguish then between descent from common ancestors on the one hand? You refute that, you're open to it, you buy it,
I'm open to common ancestry. I think that the evidence, I don't think I would go as far as Eugenie. I think there's still some question about that, but I know there are some very strong lines of evidence for common ancestry.
And so you're open to that?
So I'm open to that. That's not a problem for me, if that's how it turns out.
The mechanism, random variation and natural selection,
that I would say it certainly operates, but it's incomplete. I mean, there's no question that organisms vary, and that those that are more fit, that are adapted in some way, will go on to survive and reproduce. Okay, so the mechanism, Darwin was onto something. Question is, was he onto the whole show? Strict Darwinists like Richard Dawkins would want to say he really nailed it down. Where I would differ, I would say the Darwinian mechanism probably only counts for about 2 to 3% of what we see.
The Darwinian mechanism is a minor sideshow in the great geologic story of the planet and of living things. Is that a summation of your point of view?
Minor sideshow might be minimizing it too much. Certainly, antibiotic resistance, I think, is something you could account for in terms of the Darwinian mechanism, and that's important. I mean, it's certainly
Let me put it
important
to you this way.
Yeah.
Now, so we know, because we see with our own eyes, that within a species, you can grow sheep with longer hair or shorter hair, or you can grow hogs that are fatter or get fatter more. So we know that that through random variation or indeed intentional breeding, you can create certain characteristics within a species.
Right.
That we grant, everybody grants that because we see it with our own eyes. But you can't, or we haven't seen with our own eyes, a sheep turned into a goat.
I mean, it's the extrapolation. I mean, insects develop insecticide resistance. The Darwinian mechanism accounts for that, but how do you get insects in the first place? If the Darwinian story is
what you're
correct,
saying is that what we do see and what is irrefutable is relatively minor modulations within a species, right? Okay.
And the question is, can you extrapolate what we see going on in biology today to the past? An evolutionist would describe sheep and goats as being descended from a common ancestor, because sheep and goats actually are quite similar. But because we do accept an ancient age of the earth, there's a lot of time for it to take place.
Right, okay.
On to some specific criticisms of Darwinism, beginning with the fossil record.
I quote Jonathan Wells, "A century and a half of fossil collecting since Darwin has made it clear that fossil species tend to appear suddenly and persist unchanged for long periods of time before going extinct. That is to say, it is very easy looking in the fossil record to find full-blown species, but they're suddenly there, and then they're suddenly not there, and you don't find in the fossil record lots of transitional forms, species on the way to becoming other species, which you would expect if the theory of evolution were true."
Don't get your understanding of the fossil record from Jonathan Wells.
Well, how do you answer the argument?
He's citing Stephen Jay Gould and Niles Eldridge there,
Yeah,
really.
but what are Gould and Eldridge talking about? Gould and Eldridge are not saying that living things didn't have common ancestors. They're saying that the snapshot that we have of the history of life as revealed in the fossil record doesn't show point-by-point ancestry such as Charles Darwin thought it would.
Have the sort of gradualism which Darwin said was really essential. If his mechanism
why
was
would
going to
gradualism be essential? And,
well, he says
what
if
the fossil
it
record
could be shown that any species could not have been gotten by gradual. It's a quote from The Origin of Species that's repeated over and over again. Then my theory would absolutely, bite the dust.
Okay, so Stephen Jay Gould and Niles Eldridge, to name two of these guys, have characterized the fossil record as demonstrating something they call punctuated equilibria. There you have long periods of genetic stability punctuated by relatively short bursts of evolutionary creativity, right?
Okay.
And these short bursts, because they're so short, are very hard to find.
It's a sampling problem.
It's a sampling.
But
the
the argument
sampling problem.
Well,
and that's I think that's what raises eyebrows for some people.
The argument about punctuated equilibria versus gradualism within paleontology has to do with which explains more of the fossil record, because obviously both do. You find some sequences, particularly with invertebrates, where you have a very nice gradual record. Take a look at some of the molluscan series in East Africa. You have but we tend to think, we tend to have these blinkers on. We only think about vertebrates. And vertebrates are very unlikely to show those kinds of...
Vertebrates are? Why is that?
The reproductive cycles take a long time. An elephant takes a very long time, after all, to grow up and reproduce and so forth. And they're far rarer than our invertebrates, like mollusks and other forms that leave a very copious fossil record. That's the major reason.
What's your take on the fossil record? That it's problematic, or that?
Well, I think what it seems, if I just look at it, and I'm not trained as a paleontologist, but the sense I have is that you do have these long periods of stasis, things remain unchanged, and then these sudden emergences. Now, I think you can account for that in terms of common descent, but then you're talking about some very rapid evolution. And it's not clear at all that you've got some sort of naturalistic mechanisms, either the Darwinian mechanism of random variation, natural selection. You can supplement that with some other self-organizational processes, perhaps. But it's not clear that any sort of naturalistic mechanism that's been proposed has the capacity to account for that. And this is where it is.
A new topic. We find very complex biological mechanisms everywhere in nature. Just how well does the theory of evolution account for them?
We've got a biochemist called Michael Behe who's come up with a notion of irreducible complexity. And again, to me as a layman, reading this stuff, it seems quite sensible. So you're going to have to help me get over this one, so to speak. B, he draws a parallel with the mousetrap. It has a relatively few number of working parts, but every one of them is essential. This is what he terms irreducibly complex. Take away one piece and it doesn't work. And there are all kinds of structures, lots and lots of structures in the physical world, the living world, that are likewise irreducibly complex. He mentions biochemistry of light detection requires a whole series of complex molecules and interacting in a very complicated way. Take away a single molecule and the organism can't detect light. So the point is that it's very hard to imagine how some of these things could have evolved piecemeal. You have to imagine a mousetrap first evolving as a little piece of wood and then evolving the spring and then evolving that lever that actually, and that just seems intuitively, he says it's impossible, and intuitively to me it seems a fairly forceful argument.
Have you read any of the criticisms of irreducible complexity that have come out from scientists, from biochemists and cell biologists who actually work in these areas?
I'm waiting for you to give me, to characterize
There
them.
is a long series of arguments against this, and it's probably something that is not going to be...
I can reverse one of these arguments for you just briefly. I mean, the idea is that you not only, let's say if you want to reduce what you're calling an irreducibly complex mousetrap, not only do you remove a part, but you have to modify another part. And if you can modify, let's say, I mean, with the mousetrap, you remove what's, it's got a hammer, a holding bar, a spring, platform, and a catch. You can remove the holding bar, and then, or rather, you can remove the catch and make a little indentation in the hammer, and then basically that indentation holds the holding bar and acts like a catch. So you can reduce it in that sense. It's the notion of irreducible complexity. I mean, Behe's definition holds up. I mean, it's that you remove a part and you can't get a functional mousetrap. But if you remove and modify, then you can get something functional. And so the idea is that you can get to these irreducibly complex systems not just by adding parts, but adding, modifying, adding, modifying, adding, modifying. So that's supposed to be a way around that.
And do you think that it is? Is his argument a forceful argument against evolution or not?
I think it is. I think his notion needs a little fine-tuning, and I do that in my forthcoming book, No Free Lunch, where I argue you need not just irreducible complexity, but you need a notion of minimal complexity, so that basically you've got the simplest sort of object that does that job. So you take, for instance, what's become the poster child of the design movement, the bacterial flagellum. It's a little outboard rotary motor on the back of bacterium. If you're going to have an outboard rotary motor, you're going to have to have something that's a propeller. You have to have something that attaches that thing to the cell membrane. You need a motor that runs it. It's got to be bidirectional because this bacterium is buffeted by Brownian motion, so it's got to get through it. It's got to be able to reverse direction in order to get around. So it needs all those components. When you actually look at the bacterial flagella that are out there, because it's not just in E. coli, but in a number of different bacteria, you find that they're all substantially the same. I mean, there are few simplifications, but it's just basically attaching it to the cell membrane.
This doesn't even cause a doubt for you?
Not at all.
Not at all.
The concept of irreducible complexity has been pretty well thoroughly critiqued. The biggest problem is not whether there can or cannot be something that is irreducibly complex. That is not actually very interesting. The question is, can this be produced through a natural cause? Because that is the crux of the argument between the intelligent design proponents and everybody else.
Eugenie just teed up the next topic, the theory of intelligent design.
Intelligent design. It's a new and interesting school of thought, and you are its leading proponent. What does it say?
It says that there are reliable means of detecting design from features of the world. So you look at arrangements of matter and energy. Some of those will tell you that you're dealing with a designing intelligence, others that you're not. So let's say you're watching the movie Contact. You see, this is a movie about the search for extraterrestrial intelligence. There's a key moment in the movie where contact is established, where the radio astronomers realize that they're dealing with an extraterrestrial intelligence. This is when they get a long sequence of prime numbers from outer space. It's a long sequence. You couldn't just have, a short sequence, because that could just happen by chance, because these radio astronomers are monitoring millions of radio channels. So it's got to be a long sequence. There's complexity there. There's an independently given pattern. So the way I characterize that is in terms of specified complexity. There's complexity and it's specified. There's a pattern. And when you have that, that reliably points you to the effects of an intelligence. So that's the general sort of mathematical setup that I argue from. And then the question is, well, what happens when you apply this notion of specified complexity to actual biological systems? What you find is that some, not all, of the Behe-type irreducibly complex systems end up exhibiting specified complexity, which is a reliable marker of intelligence. Okay, that's the argument that I make.
So what you're saying then is that if you get a sheet of paper and typed on it is to be or not to be, that is the question, you know a monkey didn't bang it out, right?
Not necessarily.
There's intelligence there. But it would seem to me that from what I've heard so far, intelligent design is not taking account of scale. That is to say, if you put 1 million monkeys in front of 1 million typewriters and let them bang away for 10 billion years, sooner or later, one of them will type out to be or not to be. That is the question.
Well, you can
speed up
maybe
the
get to be or
process, too.
not to be, but you're going to maybe, I've done actually the calculation because I'm writing a book where I actually do this. How much of Shakespeare's Hamlet could you get if every elementary particle in the universe were a monkey typing at the Planck time, you know, for the duration of the universe? And you get about three or four lines of Shakespeare's Hamlet. That's it.
But this is irrelevant to our
why is that?
discussion. Because what we're
It's-
talking about is the difference between natural selection as a natural process that produces something and, quote, intelligence, by which, and we can argue, I believe he means divine intelligence as opposed to natural intelligence. You got 1 million monkeys sitting there typing on their
Right.
machine. If you want to make this an analogy that makes sense from the standpoint of
Right.
evolution, you've got 1 million technicians standing behind them with a very large vat of whiteout. And every time the monkey types the wrong letter, you correct it. That's what natural selection basically does. It's not just the random production of
it's
variation.
constantly culling the useless
Yeah, exactly.
variations.
And you're going to get...
And
you're
keeping the
And the computer
useful ones.
programs that have been written to do this get Shakespeare written pretty fast.
Okay, now,
Let me try to clarify this point. Is it possible to prove the theory of evolution beyond all reasonable doubt scientifically?
what test can evolution be put to that makes us feel more confident that it's a reliable explanation than is
What
intelligent
test
design?
how do you test
No,
whether...
we'll get to him in a moment. The first
Okay.
question is, what test can evolution be put to?
Well, Darwin himself, well, natural selection you're talking
Natural
about.
selection.
Okay. The natural selective argument can be tested. In fact, Darwin himself suggested a test for it. He said if you could find any complex structure that existed in an organism that was solely for the advantage of some other creature, that would truly destroy his theory. Because the argument is that there's a...
That, however, is attempting to prove a negative. That is proving why the theory would be wrong. What I'm
No,
asking
no,
for
all
is
you have
positive
to-
proof
no, no, all
that the
you-
theory is right.
Oh, well, that natural select... We already agreed natural selection works.
We did agree that natural selection
But isn't
produces
that what we're
minor
talking-
variations. What I'm asking for is explanations of
That that
Of
evolution would that
account
natural
for-
selection could account for common ancestry.
Yes, exactly.
Okay. Well, consider what we're dealing... This is why I brought up the age of the Earth. This is why I brought up the fact that we have lots and lots
Right.
and lots of time. Because what we see when we look at variation, which is really a way of saying genetics, okay, we have heredity. Stuff gets passed down from generation to generation. The genetic variation in a population shifts depending on what the environmental circumstances are. We have examples that we can see in the natural world where widespread populations species that are widespread over a large geographic area, peripheral groups, peripheral populations of that
Right.
widespread species can get cut off from the main body of the species,
Right.
by which that means that they're no longer exchanging genes.
Right.
And we're not talking about individuals. We're not talking about that sheep evolving into that
Right,
goat.
but
We're talking about
entire
a bunch
populations,
of
right, sure,
organisms. Yeah.
mhm.
And when you disrupt the genetic flow from that peripheral population to the rest of them, changes can take place in that peripheral population. This has been done experimentally, and this has also been inferred.
But big
granted.
changes, not changes of the kinds of the sheep who
Well,
no longer hair.
Again, over how long a period of time are we talking about?
but
We've
I mean,
never
see-
observed this for 10 million years, which is what we're talking about when we're talking about geological time.
So, I mean,
but
it could
why would
be-
you argue that the mechanism that we can observe...
I'm not arguing anything, I'm asking a question.
Okay.
Can a test be designed that would make me feel confident that evolution does in fact explain the descent from common ancestors? And it sounds so far as though there are all kinds of things that make it seem extremely plausible. But if it is the case, and it seems to be the case, that you can't design a test that will take place within the lifetime of one of us, that would indicate it does not live up to that signal criterion of a theory that it is falsifiable, that it can be tested.
Okay, now
it could be,
Okay,
it could
but
be
we've
that
shifted
because
gears
we're
here.
talking about eons and eons, no test can be designed. But that's that's all I'm asking.
But now you just shifted gears on
Why
me.
is that?
Because first of all, I think we were talking about whether natural selection can bring about descent with modification.
Yeah,
and it's
big-
clear that
big
it can.
changes.
I mean, yeah.
Right,
Okay,
little
but it seems like you've just shifted gears on me to ask whether I can refute the idea of common descent itself, which can also be done. In fact, the anti-evolutionists have proposed this for a long time. If you find human bones down in the Cambrian or down in the Permian
that
age
would
of
be clear.
fishes,
No, I didn't mean to.
So there's two
I
things.
didn't mean
the
to shift
mechanism,
gears there. I
the
didn't mean to shift
mechanism
gears.
and the
Bill,
process are different. The mechanism and the
Testability.
event is different.
Can intelligent design be tested?
Yeah, I would say so.
How is
I mean,
that?
Darwin's theory is that basically it's a divide and conquer approach. It's basically what seems to be vastly improbable, these vastly improbable systems that you couldn't get at one great leap. You can break it down into some manageable steps, and each step has to confer some sort of selective advantage. The thing is now, are there systems where you cannot find a gradual, step-by-step increase? Let's say you have a system which does not have a bacterial flagellum and one that does. Can you demonstrate reliably that that sort of transition cannot be affected? Okay, that would be confirmation for intelligent design. That's the sort of in-principle argument that we're trying to make. It's not an argument from ignorance. Okay, now so what would it mean to test it or falsify it? Okay, it would be to show that there are, in fact, gradual roots to these sorts of systems. So there's a real question. Are there systems that are not accessible by gradual Darwinian roots? Or are all such systems that we see in biology accessible by gradual Darwinian roots? And if you can show that there's a difference in the type of systems where one cannot be accessed that way, then you have confirmation for intelligent design. On the other hand, if everything is accessible by these gradual roots, then I think you've got confirmation of Darwinism.
Doesn't sound good to me. I mean,
doesn't sound like
what he's saying is that if we can't explain it through natural selection, it defaults to design, and we really.
All right, let me try one last time on this issue of plausibility versus scientific proof.
It could have been that my little mind was just pursuing a wrong question here, because I was thinking in terms of, can an experiment be devised that's conclusive or pretty conclusive on either your point of view or your point of view that could take place within one person's lifetime? Can we actually test these things? And it doesn't sound to me as though, it sounds to me as though you're kind of adducing, there's a weight of evidence and plausibility. It really is not an experimental matter. That we can't quite get to on either case.
Well, I think if you could show gradual Darwinian means to systems like Michael Behe points out, bacterial flagellum, blood clotting cascade, I think eventually these design arguments would just pass away.
So can anybody show them, or is it just a question of arguing how plausible they are?
Actually, there has been, as Bill pointed out, a fair amount of work on the bacterial flagellum, and there's been work on the blood clotting cascade and the other things that Mike says are irreducibly complex. But the problem with that is, let's say that we come up with a really plausible scenario for the bacterial flagellum. The intelligence design people just say, okay, that's not irreducibly complex, but this still is. And so you're spending your whole time kind of brushing crumbs off the table.
You haven't even come close to explaining systems of this complexity. So,
the young-earth creationists keep saying there's gaps in the fossil record. We'll never convince them. We'll never convince you.
Thousands of papers
I'm still a little nervous about the fossil record myself.
You need to know more about it, honey.
Oh, do I? Okay, listen. We've got to wrap it up. It's television. William Dembski, I quote you, in the next 5 years, intelligent design will be sufficiently developed to deserve funding from the National Science Foundation. Jeannie?
Good luck.
You laugh him to scorn?
No, I don't.
Oh, you don't?
I
you think
do
he's
not.
onto something? It's a serious intellectual pursuit.
No, listen, this is something that I do want to get clear. And I maybe more so than many of Bill's critics of intelligent design have often said, look, you are presenting a scholarly position, defend it. There have been a lot of criticisms. He's working on answering his critics. And maybe in 5 years or 25 years or day after tomorrow, maybe everybody will smack themselves in the forehead and say, yes, intelligent design is it. But until that happens,
has he gained any purchase on your mind at all?
Until that happens, it does not deserve to be taught in high school, which is what the intelligent design people are arguing.
Okay. Now let me put I've had her comment on you. Let me ask you to comment on Charles Darwin, not on Jeannie, of course. But so we've got this fossil record. Am I being a little bit zhuzhan and naive about the fossil record? Am I going after something that really isn't a problem, properly understood?
There are lots of structural transitions in the fossil record.
There are?
For
The thing
group
is,
after group.
you know, in science, you've got facts and data, but then you try to put it together with various patterns. And the interpretive moves you make, you know, if you're wedded to Darwinism, you'll make it fit. You know, if you're not, it's going to look like a hard fit.
So your charge against Darwinism is that it's at this stage of the game, 130 years after Charles Darwin's voyage on the Beagle, it looks contrived. It looks like a theory under immense pressure.
Yeah, it's certainly a theory under pressure. I mean, especially when it tries to make these totalizing claims, that it's the mechanism that accounts for most of biological complexity and diversity.
Do you feel that evolution is under pressure or still sort of triumphant?
I know that through repetition, various anti-evolutionists, including design people, have argued that evolution is a theory in crisis, but you sure don't find that if you go to universities.
It's just not the case at all.
It's just, no. I mean, people are mystified by this claim.
Jeannie and Bill, thank you very much.
Thanks.
I'm Peter Robinson for Uncommon Knowledge. Thank you for joining us.
Funding for this program was provided by the John M. Olin Foundation and the Star Foundation.
This is PBS.